Today we're going to start section 5.5, if you were absent, multiple angle and power reducing formulas. So example 1, we're going to solve 2 cosine x plus sine 2x equals 0. So this is largely like section 5.3. We're trying to solve it, get the trig functions by itself, and use the unit circle. But in this one in particular, we have this strange 2x here. And that's the first time that's happened. So on your unit circle sheet, right under the unit circle, you see these double angle formulas. So sine of 2x, 2u has one formula. Cosine actually has 3. And tangent has 1. So we have, in this problem, we have the sine of 2x. So we're just going to use the double angle formula to rewrite it. Leave this first term alone. And sine of 2x is the same thing as 2 sine x cosine x equals 0. And from this point forward, this is just a problem like you did in section 5.3. You just want to solve it, like factor it to try to get these trig functions by themselves. And on this one, you notice you've got 2 cosine x in both, so you can factor it out. That's your GCF. What's left here when you factor 2 cosine x out is a 1 plus, and what's left here when you factor 2 cosine x out is a sine x. Then you set both your factors equal to 0. And divide by 2 on this one, you get cosine is 0. Minus 1 on this one, you get sine is negative 1. So cosine is 0 at pi over 2 and 3 pi over 2. And sine is negative 1 at 3 pi over 2. And they did not restrict us, so we say plus 2n pi for all 3 of these. And these are actually the same, so you would only really have to write it once. But so that's what's new, is that we have this double angle that we need to change using the double angle formula. All right, example 2. All right, for example 2, we're going to use the following information to find tangent of 2 theta. And the first thing I think I'll do is look at the tangent of 2 theta formula. And it is 2 tan theta over 1 minus tangent squared theta. Okay, so we looked up the formula that we need to fill out. And secondly, we're going to use this information to draw our triangle. This means we're in the 4th quadrant, and then go perpendicular to the x. Theta at the origin. If cosine is 5/13, then this is a 5/12/13. It's often going to be a 5/12/13 or a 3/4/5. You're not making a state Pythagorean theorem. And that 12 is a negative because it's below the x-axis. Alright, so now all we do is fill out our formula. It's 2 times tangent of theta would be TOA over 1 minus, just let me remember that this is the same thing as this squared. So I'm going to use that tangent of theta, that negative 12 is, and square it. I'm going to use this form. Alright, the numerator, you'll put that over 1, you'll multiply, and the denominator, you'll square 12 fifths, negative 12 fifths. Let's rewrite the numerator and leave it alone. And in the denominator, this 1 minus 144 25ths is the same thing as 25 25ths minus 144 25ths. So we would subtract those and get negative 119 25ths. And the way we divide is we keep change flip. And let's see, we're not dividing anymore. goes into 5 months. Pi goes into 24 5 times. So that answer is a negative times a negative is a positive 120 over 119. Okay, let's do example 3. Okay, so I'm hoping this one you'll just kind of watch the process. We have the sine of this multiple angle, 3x, and they want us to rewrite it as the sine of a single angle, 1x. So the first thing we might do, since there's no triple angle formulas, we have double angle formulas, but no triples, is we might try to rewrite 3x as addition. So sine of 3x is the same thing as sine of 2x plus x. We could rewrite it that way. And then that's the sine of u plus v from the other day. I'm just going to write it here, which is sine u cosine v plus cosine sine v. That's a sine of a sum formula from the other day. So that means that when we do this side with our u and our v, we get sine 2x cosine x plus cosine 2x sine x. And we'll just kind of get everything to sine of a single angle. I'll see this next. So I can use my double angle formula there. 2 sine x cosine x. And then we just need to bring this one down. And here, this is a double angle for cosine. And I've got options, which one I want to choose. And I'm looking at all 3 of these, but I know the directions want me to only get it down to sines. So this would be the one I would want to choose since it's only sines. 1 minus 2 sine squared x. So we'll write that as 1 minus 2 sine squared x times sine x. Let's see. Looking at this term, we have these that we could multiply together. 2 sine x, we'll multiply those like bases and add their exponents. And here we'll distribute minus 2 sine to the third x. And then one of the last things we'll do is we'll use that trig identity to rewrite cosine squared. So we could do 1 minus sine squared x, rewrite everything else. And then lastly, we'll distribute here. So that's 2 sine x minus 2 sine to the third x plus sine x minus 2 sine to the third x. Then these are like terms. So 2 of them plus 1 more is 3 of them. And then negative 2 of these and negative 2 more is negative 4 of them. And just to double check, what they wanted us to do is to leave it with sine x. And this is because this last term, that 4 sine to the third x, could be written in a different way as this. So our entire answer is in terms of sine to the first power, which is what they wanted. Alright, last but not least, you're going to look on the circle, on your unit circle chart for these power reducing formulas. So right under the double angles, we're going to look at power reducing. And what they're going to do is they're going to take second powers down to first powers. So take a power of 2 down to an understood power of 1 right there. So it's reducing the power. So example 4, rewrite sine to the fourth x as a sum of first powers of the cosines of multiple angles. Okay, sine to the fourth x as the sum of first powers of cosines of multiple angles. All right, so first powers, multiple angles. Okay, so first off, let's just say I don't have a way to reduce a fourth power, but if I change that to sine squared x times sine squared x, then I could use this new power reducing formula, and instead of sine squared, we could do this formula. 1 minus cosine 2x over 2. 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2. All right, we get FOIL across the top. It'd be 1 minus cosine 2x for outer minus cosine 2x for inner plus cosine squared 2x for last. All over the denominator times the denominator would be a 4. Okay, so we're going to bring 1/4 to the front rather than divide it all by 4. Leave a 1 alone. These are like terms that we can combine. Oops. One of these cosine 2x's and one more gives us 2 of them. Alright, let's see. We're all in cosine, so that's great. They wanted multiple angles, but they want the sum of first powers of cosine. So this one's a sum of a first power of cosine, just a double angle, which multiple angle they want. So this is the only one we need to rewrite. So this is going to be 1/4, 1 minus 2 cosine 2x. Those are fine. But we'll use the power reducing formula for cosine squared. Cosine squared is 1 plus cosine 2u over 2. Cosine squared u is 1 plus cosine 2u over 2. So that's the formula we're going to use. And our u is 2x. So if you can focus in on this formula, we have cosine squared 2x. So when we run it through this formula, it's going to be 1 plus cosine 2 times our u. So 2 times 2x over 2. So I'm going to write down plus 1 plus cosine 4x over 2. So in order for us to change this term here, we looked up this formula up here, and we ran it through the formula, but we had to notice our angle was not just a simple u, it was 2x. All right, let's do some I love math right here. Separate that fraction. That's cosine 4x over 2. And then, let's see, equals 1/4. A positive 1 and a positive 1/2 is a positive 3/2. There's nothing to combine with this one. And I'm out of room, but there's nothing to combine with that last one either. So that's a great answer. The other thing you might do is you might distribute the fourth and call it 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. All right, so that's it for today. These are the ones that I've posted for you on Facts.